Hello everyone. In this video we're going to be denesting a radical. What does denest mean? We have the square root of something plus the square root of something else. Notice that this number is under two radicals. That makes it 2 radical, right? So we're gonna kind of get rid of one of the radicals. In other words, we want to write this as a sum of 2 radicals, like square root of x plus square root of y. Or we could write it something like a plus the square root of b. Given that a could be an integer or a radical, but let's probably go with this, something like that, okay? How do you do that? When one way to look at it, there's a lot of ways to look at it, by the way, at least 3, I think. We can first write it like this, and then square both sides. All right? When you do, you'll get this. Of course, this is still under the radical. This, oh, come on, Notability, stop acting weird. Or the pencil, I don't know. Now we're going to compare rationals with rationals and vice versa. This is irrational, so this must equal this, and this must equal this. Get it? X plus y equals 16. Uh-oh, that was easy. And 2 root xy equals square root of 255, which of course can be simplified by squaring both sides like this, okay? And solving this system is actually fairly easy. You can do a bunch of different things like substitution, definitely, like this, and plug it in here. Or you could square this and square that, I mean x minus y. There are differences always for xy. You know this, you know that. You can find this, and then this, and this. You can find x and y. You get the idea? This. I meant coming up with a system of equations with x plus y, x minus y. Okay? Whichever you like better. You decide. All right. So we got the answer though, right? Didn't we? Let's find out. This is 256. This will also be kind of like an eye-opening experience. You know why? Because you'll get to see how this works. This is 255. Notice that from here this needs to be 1. Okay, great. I hope the pen works. Sometimes it just stops working. I don't know. So from here we get this. Yeah, I just want to act weird sometimes. And we get 2 results. I'm going to write fast so it doesn't act up. Now, along with this, we got a system, right? You know. See, so the only thing that happens is they just switch places, and it doesn't matter because there's a plus sign. So you don't really care about 2 solutions. You just need 1. So to keep a long story short, again. Uh-oh. Come on. All right. This one was able to be written as follows, right? Now it's going to become square root of 15 over 2 plus square root of 17 over 2. And or you can switch them around. I guess writing the bigger one is kind of looks better, I think. All right. So now what do? You kind of think of this as this, and this, and then this, divided by this. Okay, I use all of this. And then, don't diss me for that, okay? Root 2 over root 2. That's a 2. The numerator is root 35, 34 plus 30. Okay, here you go. That is probably the simplest one. And this is what I mean by denesting, because if you pay attention, numbers are only under a single radical, each one. You're going to look at each one. Okay, so how do we systematize this? How do you make it systematic? So if they give you any radical, right? So you can think of it this way. All right, I do need a 2 in front of the radical. So I'll divide and multiply by 4. Inside I'll get this. My goal is to factor this number into 2 factors such that their sum is 16. You get the idea? That's a shortcut. Okay, 255, and I want the sum to be 16. 5 times 51 will work. The problem with that is their sum is 56 over 2, which is 28. By the way, this is also denestable. I just realized, but it gives you a different answer. That's not what we're looking for, right? So what do? You look for other factors. Let's try something else. 5 and 51, not a good choice. Maybe it's divisible by 3, right? I think it's 3 times 85, right? Yeah. But with the 85 and 3, like, of course you have to have the halves. Their sum is going to be bigger. So I think the numbers need to be closer. So let's factor 255. 5 times 51. I got it. This is 3 times 17. This is the product of 3 primes. That's why I couldn't get it before, right? So we used 5 and 51. This didn't work, right? All right. And we used 85, which is this one with this. So we kind of paired up that way, but we didn't use 15 and 17. Yes, that's the thing. 15 and 17 are going to work. You know why? Because I know the answer? No. Because they're close, first of all. And then second, their sum is 16. Look at that. 32 divided by 2. There you go. You got it. It's going to look like this, and the rest is easy. Same thing, same thing. But of course, we need a 2, because if you think about it, square root of x plus square root of y squared is x plus y plus 2 root xy. If you square root both sides, you're going to know what I'm talking about. This is what we have. Get it? And this is what we're trying to get. Okay. This is given. This is the goal. Okay. So that's basically it. But I also want to tell you something. There's actually a shortcut, like a formula. So whenever you have something like square root of a plus bi, square root of a plus bi, I was about to say that, can be written as the square root of a plus the square root of a squared minus b divided by 2. And then same thing with the minus sign. Make sense? Okay. In this case, one of the things that's significant is that if you square this and subtract from this, you always get a perfect square, which works nicely so that you can denest. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.